Today, we are diving into the framework that gives AI something it's always been missing: memory, reasoning, and maybe most importantly, the ability to recover from its own mistakes. We're talking about LangGraph. And trust me, it's changing the game for how developers build truly intelligent applications. Think about the smartest AI assistant you've ever used. Not the ones that forget who you are after one question, but the ones that actually remember your conversation and handle complex multi step tasks. Well, today we are going under the hood to see how that kind of intelligence is built, because this is what takes AI from being a simple calculator to a dynamic problem solver. To really appreciate LangGraph, let's start with how AI apps used to work. Most basic AI systems are linear. You give them a prompt, they give you a response, one input, one output. End of story. That's fine for quick answers or simple use cases. But what if you're building an AI that manages a complex research project or handles an entire customer support journey? For that, you need something more advanced: a system with loops, decisions, and memory. In short, you need something that can actually reason. And that's where LangGraph comes in. And the core idea is beautifully simple. Instead of building AI as a straight line, you build it as a graph, a network of intelligent connections. LangGraph lets developers design their AI like an intelligent flowchart, or each step knows what's already happened. That's what makes the system stateful, meaning it can remember and make decisions based on its history. It's the difference between a tool and a thinking partner. This concept actually builds on a classic in computer science, the directed acyclic graph, or DAG. A DAG is great for workflows where steps follow a strict order, like baking a cake before you frost it. But here's LangGraph's real breakthrough: it allows cycles. Cycles let your AI loop back, retry steps, or even rethink earlier decisions. And that's absolutely crucial for real intelligence. To start building with LangGraph, you only need to understand three basic building blocks: state, nodes, and edges. The state is your app's shared memory. Think of it like a central nervous system or a whiteboard that every component can write on. Each node can read from and update it, so the whole system knows what's been done so far. That's what creates one continuous, coherent thought process. If the state is the memory, then the nodes are the muscles. These are the doers, the parts that call an LLM to generate text, run a function, fetch data, or execute custom logic. Each node is a specialized worker, ready to perform its task when called. And then we have the edges, the arrows that connect everything. They decide how information flows from one node to the next. But here's where the real magic happens. Edges aren't just lines, they can contain logic. LangGraph's secret sauce is something called conditional edges. These edges look at the current state, the memory, and decide what to do next. Instead of following a fixed path, the system makes dynamic choices on the fly. Let's say a web search succeeds, great, move forward. If it fails, no problem, route to a error handling node. If the AI realizes it needs more information, it can loop back and ask you a clarifying question. That's how you get advanced agent like behavior: AI that can use tools, recover from mistakes, and reason step by step until it finds the right solution. And this isn't just a concept for cool demos. LangGraph's graph based design is built for real world, production grade AI systems that can handle the messiness of live environments, where tasks fail, users pause, or systems crash. Features like persistence let your AI save progress and pick up later. Fault tolerance ensures one small error doesn't take down the whole system. And checkpoints, may be the most important, let you save the graph state at any point in time. If something goes wrong, your AI just picks up where it left off, no memory loss, no resets. With LangGraph, we're finally moving beyond one shot AI. We're building systems with memory, logic, and resilience baked right in. This opens the door to automating complex multi step processes and solving problems that were completely out of reach just a few years ago. The question now is, what will you build with it?